Alright, let's just start off with a ramp, just some normal ramp. And I have here a meter stick, so this is 1 meter long. So I'm just going to measure the length of my ramp here. It looks like it's 1, 2, 3, 4, 5, 6, about 6.8 meters long. And this angle here is 33 degrees. Now before teaching about the actual sine law, let's actually just look at what sine and cosine mean. Here we have a 33-degree angle, so might as well start with the sine of 33 degrees and the cosine of 33 degrees. Now the first thing I notice is this RAD here, radians. We do not learn about radians in this course. We learn about degrees. So here's degrees. Let's press this button. There it is. And now we're going to get correct answers. Otherwise, the answer we would get for sine and cosine would be incorrect. Now that that's out of the way, on this calculator, you don't write sine 33. That's not going to work. Here, you actually have to write, so clear that out. We're going to write 33 sine. And it tells me that the sine of 33 degrees equals 0.5446 approximately. Now, what does that mean exactly? Well, if I draw a line straight down from the ramp to the ground, then the height of this line is going to be equal to about 54.46%. So 0.5446 is equal to 54.46% of the length of my ramp. So make sure when you put 54.46% in your calculator, you write it as 0.5446. So it's 54.46 divided by 100. That's what percent means, divided by 100. And then you multiply by the length of the ramp where you're measuring up to, and that'll give you the height at that point. So for here, 0.5446 times 6 is equal to about 3.268. And so this height right here is 3.268 meters approximately. Now I can move this green line up or down this ramp as far as I want to go up, as far as I want to go down, and it'll tell me the height at any point. Just multiply the sine of 33 degrees, which is 54.46%, and this height will be about 54.46% of the ramp length. So the height is a little more than half of the length of the ramp. It's like 54% of the length of the ramp here. Now this particular ramp we made 6.8 meters long, and so the height at the end of this ramp is simply the sine of 33 degrees, 0.5446, times 6.8. Now the cosine of an angle is very similar. The cosine of 33 degrees is about 0.83867, or let's say 0.8387 rounded. That means that this line here will be about 83.87% of the full thing. So just under 84% of the full thing. So you see it's a little longer than the height. So just multiply that percentage by the length of the ramp to that point, and you've got yourself the length of this. In this case, the length across for the whole ramp will be 5.703 approximately. So that's a great way to define sine and cosine. If you can take any angle, whether it stands alone or it's in a geometric shape, and you can just kind of turn your page so that one leg of the angle is flat along the ground and the other one is going upward at some angle, well then the height of that ramp at any point is always going to be a certain percentage of the length of the entire ramp. And that percentage will always be the sine of the angle. Also, the length across of the side that's on the ground will also be a certain percentage of the full ramp length at that point, and that percentage will be the cosine of that angle. Now, just as a quick aside, you may have noticed that this formed a right triangle. And since it did, then the Pythagorean theorem should stand. So since we said that this side length here is the cosine of 33 degrees times 6.8, which is the length of the ramp, and this side here is the sine of 33 degrees times 6.8, which is the length of the ramp. So about 3.704, about 5.703 for those two sides. And of course, the length of the ramp is 6.8. Well, the Pythagorean theorem says that this side squared plus this side squared is equal to the longest side squared. Well, this side down here is cos of 33 degrees times 6.8. This side over here is sine of 33 degrees times 6.8, about 3.704. The other one's about 5.703. If we don't round either of these, we square them both and add them together, you'll see that we will get exactly 6.8 squared. Take the square root of that, and you get 6.8. So it's just a fun little thing to see that the Pythagorean theorem still stands perfectly if you find these sides legitimately using sine and cosine. That makes it also an easy way to check your work if you're working with sine and cos. Now what happens if I change the angle or change the length of the ramp? Well, nothing changes, right? For example, this new angle is 53 degrees instead of 33 degrees. And I made the side length a little bit less, 6.5. And now that we know about sine and cos, we could figure out the height of this ramp to the tip and the length from left to right all the way to the tip just by using cos and sine. So the sine of 53 degrees, it says, is about 0.7986, or another way of saying it is 79.86%. That means that the height of the ramp is about 79.86% of the total length of the ramp from here to here. And the length on the ground from this point all the way to the right, which is directly underneath the tip of the ramp, is going to be the cosine of 53 degrees times the length of the ramp. Well, cosine of 53 degrees is about 60.18%. So it's going to be about 60.18% of the total length of that ramp. So as you can see, sine and cosine are basically telling you what percentage of the hypotenuse these other two sides are when you have a right triangle. That can be extremely useful when you're trying to solve triangles. Now what happens if I make this angle like 90 degrees and beyond? Well, let's try something. Let's try it at 90 degrees, and let's try it a little bit more later. So now this ramp's pointing straight up and down, so a 90-degree angle. The length of it here I measured at about, let's say, 5.96 meters. Now, the height at the very top of this should be 5.96 meters because it's going straight up, so the height is the actual top of it. But the angle is 90 degrees, so we do sine of 90 degrees times 5.96 to see exactly what it equals, and sure enough, it just equals 5.96. So the 90-degree angle doesn't really ruin anything here. What about the cosine? Well, the cosine should give us the length left and right. Well, it goes straight up. So the length left and right is actually 0. It doesn't go left or right. And so the cosine of 90 degrees times 5.96, sure enough, is just equal to 0. It doesn't go left or right because the cosine of 90 degrees is equal to 0. Now let's see what happens if we move the angle beyond 90 degrees. Let's go over here to about 130 degrees. The length of this is 3.5. My calculator says, so sine of 130 degrees, 0.7660 approximately. So this is going to be 76.6% of 3.5. So the height here is about 2.68. And the distance to the right is going to be, let's do cos of 130. So interestingly, cos of 130 is negative 0.6428 approximately. That means it's going to be negative 64% of the length of this ramp. So multiply that by 3.5. That's the length of the ramp. And it says it's going to be negative 2.25 approximately meters. Well, why does it say negative? Well, because the cosine is measuring the length of the ground from this point here to the right. So since we're now tipped over to the left, you're going to see a negative number. That would actually work if I went beyond 180 degrees for sine. The sine of, like, let's say 190 degrees, if you check in your calculator, will also be negative because the height will then be negative once you go below the ground. All right, let me give you a couple of questions as sort of like a checking understanding. So I'm going to make this length pretty long, and I'm going to make it a 21-degree angle here. All right, let's say this is 8.2 meters long. How tall is this ramp, and how far to the right is this ramp? Now pause the video and try to do the work on your own and come back to see if you got it right. But as an extra challenge, because the communication is important, try to see if you write it exactly the same way I write it. If you do, then that's bonus marks for you. All right, for the height right here, all we have to do is say that A equals sine of 21 degrees times 8.2, which is approximately 2.94. So this height is about 2.94 meters. And the length along the ground here is cosine of 21 degrees times 8.2, which is approximately 7.66. And that's in meters as well. Now I'm going to give you another little challenge. I'm going to put this angle over here. I'm going to say that this is 4.8 meters, this ramp here, but the height of it is 4 meters. I want you to tell me what this angle is in here. Pause the video, figure that out. It's going to take a little bit of thinking this time. Come back and see if you can do the same as me and get the exact same answer with the same communication. And when you're done with that, I'd like to know this length down here as well, using the skills that you learned today. All right, we know that this side here is a percentage of this largest one. And the percentage is, since this is the opposite of D here, the percentage is just sine of D. So we know the percentage of 4 out of 4.8. To find that percentage, we could just say 4 divided by 4.8. That'll give us the percentage of this compared to the largest one. All right, 4 divided by 4.8 is about 83.33%. So I know that the sine of D is 83.33%. Now what is the angle D? We have to find the angle D that will give us sine D is this percentage. Well, the only way to do that is to do the inverse operation. So let's put in 0.83333 repeated and take the sine inverse, see what we get. All right, it says 56.44 degrees. Therefore, this angle D must be 56.44 degrees, approximately. And now that we have that angle, we can easily find the value of this C. So we just say cosine of 56.44 times 4.8 is equal to C. So C equals 2.65 approximately, and that's in meters. All right, similar to the last task, I'm going to keep the ramp at 4.8 meters, but I'm going to change the angle here. And this length down at the bottom, I'm going to say is 4.1 meters. I want you to tell me the new angle. Pause the video, come back, and try again to get my form exactly as well, because you want to work on communication as well. All right, we know that this length is just a percentage of this length right here. And since it's the adjacent side to E, we just have to say the cosine of E is that percentage. So we can say that this 4.1 is equal to the cosine of E, which is the percentage, times 4.8. Or we could just say that the cosine of E is equal to 4.1 divided by 4.8. 4.1 divided by 4.8 will just give you that percentage. It's a bit like saying if you got 52 out of 57 on a test, then what is your percentage? Well, the percentage is 52 divided by 57. It's the amount that you have divided by the total. Well, here, 4.1 is what percentage of 4.8. So you just have to do, it's like 4.1 out of the full 4.8. So 4.1 divided by 4.8 is the percentage, and that'll be just equal to the cosine of E. 4.1 divided by 4.8 is 0.85416, which means cosine E must be 0.85416. And to find what E is, just take the cosine inverse of that, and it's approximately 31.33 degrees. As an extra task, try to find little e as well, right here. Alright, so you might have noticed that before I was defining this side length as the sine of this angle times the ramp length. But then when I gave you the side length and the ramp length, now I was defining the sine of that angle as this height here divided by the ramp length. Alright, so it's the same thing, it's just, the inverse operation. Sometimes you have to do the inverse in order to get the original. And that is sine of an angle is just equal to that opposite length divided by the hypotenuse. That's part of SOH. If you notice, sine of an angle is equal to opposite over hypotenuse. And we also did the cosine. Cosine of that angle was equal to the adjacent side divided by the hypotenuse. That's the SO and the CAH part of SOH. Now the TOA part of SOH is the easiest of all of them. The tangent of any of this ramp, as long as this side is on the ground, if you place this side on the ground and the ramp goes up, the tangent is just the slope of this ramp. Well, the slope is rise over run. The rise is this height and the run is this length. So the tangent of the angle is simply the opposite side divided by the adjacent side. And as you can see, TOA stands for tangent of an angle is equal to the opposite over the adjacent. Now let's see if you understand that. I'm going to change the angle and the ramp size here. I'm not going to tell you how long the ramp is, and I won't tell you the angle. But I will tell you that the height is 5.5 meters, and the length along the ground here is 4.78 meters. I want you to find that angle, and I want you to find the length of the ramp. Pause the video again, do your work, and come back and see if you can get it. Alright, we know the tangent is just the slope, which is the rise divided by the run. So I could just say that tan of f equals 5.5 divided by 4.78. So the tan of f is equal to approximately 1.1506. And if you take the tan inverse of that number, you will see what f is. F is approximately 49 degrees. Alright, let's take the sine of this angle and we get 0.7548 approximately, which means that 5.5 is about 75.48% of this G. Now we could just divide both sides by 0.7548 and we get G is equal to approximately 7.287.